Right.
In millions of events.
Thank you very much, everybody, for coming to the meeting, and thank you all for actually sticking around to the end. It is much appreciated. I'm going to talk to you a little bit about technical and analytical error in clinical flow cytometry. It will cover electronic trials, it'll cover some of the issues that we've just been talking about now with plasma cell myeloma, MRD. But before I start, I will just sort of say, this is the UK NEQAS. We're talking about the findings and things that we've done over the last 12 months. Some of these projects have been things that we've looked at, some of the projects have been with your help, so thank you very much. A couple of the things we're not reporting on, though, because we've only just sort of gone live with them. We've now got a pilot program for CSF. I don't know if anybody's enrolled in it, but if you're not and you were testing CSF, you might be interested in that one. The first samples are actually going out this week, because we like keeping busy, so we've got some data on that soon. And we've also got another digital morphology program. It's quite a long name, Haemato-Oncolocy Bone Marrow Aspirate Assessment Program, but it's intended for people that are looking at bone marrows. So if you've got clinicians or scientists that are looking at bone marrows on a regular basis, we've now got an EQA program for that. And again, we're going to be launching the file of the program. It's going to be going live this week. Then we're going to be issuing, I think it's about 4 or 5 trials a year. So again, these are programs that are just developing and might be useful for you, particularly the latter one for bone marrows, because we've been made aware by Steve that NEQAS are looking at things like that in terms of staff that are looking at bone marrow reporting. So you might as well save yourself getting a non-compliance. Anyway, technical and analytical error in clinical flow cytometry. As with Alison, I'll say apologies to anybody in Thessaloniki. I did talk a lot about some of this stuff whilst I was over there. So, ISO 15189. Laboratories shall have got a documented to identify and manage non-conformities in any aspect of the system, pre-examination, examination, or post-examination. ISO 15189. FCS file analysis is the main area of analytical variation in flow cytometry. Once we've got the data filed, we've seen it. Different members of staff will analyse things differently. We've seen it in Alison's presentation, and we've been seeing it for years. And you all know that all staff that perform an analysis of flow have got to be properly trained and have got to be competent. So to sort of assess some of this, what we decided to do was run some electronic trials in silico, if you do the Latin. We did 34 stem cell enumeration and for the MRD of ALL. We've excluded CD4 enumeration at this time because 95% of it is just done through automated software, so we couldn't see the point. We've not done a PNH yet because we decided to wait until the new guidelines were launched. And we've not done low-level leukocytometry because there's so few labs that actually do it. But a PNH trial is going to be coming in the next couple of months because we've been working with Steve to get some data sets. So we've issued 2 electronic trials for CD34 and 1 electronic trial for MRD. Now the CD34 electronic trials, we've done 2, one in May last year and one in August last year. Issued it to all participants in the CD34 program, so we've got 113 returns for the first trial and 84 for the second. But what actually made the first trial a little bit more interesting was that the second sample, EDU2, was an artificial FCS file. It wasn't from a patient. We used some software in the office to create a fake patient digitally because we want to see if we can start doing that and actually creating FCS files that meet your requirements. If you wanted certain antigens to have weaker expression and stronger expression, we just thought it'd be nice to know if we can do that, and it turns out we can. So that's quite cool. So, as I say, sample EDU2 was constructed by us. We used sample EDU1 as a baseline, and then we sort of, I'll just use equivalent of Microsoft Word on a little bit more of a complicated piece of software. And we put everything together so that the CD34 percentage values and absolute counts differed between EDU1 and EDU2, but the non-CD34 events, the bead count and the sort of normal white cell events, were actually identical data. So this is EDU1 and EDU2, just next to each other. Not sure which one's the laser. Not that one. There we go. You can see they look fairly similar, apart from you can see some differences there on the CD34 side scatter plot. But a lot of the events, you can see the bead cloud there on forward side scatter is identical. And again, it's identical there because the bead populations are the same. Just to prove it, just a few gates. Population A, which is the sort of 86918, 86918. Population B for the beads, 11367, 11367. And then population C, which I know is eventually going to end up being the CD34 stem cells when we follow the ICH strategy through. I'm just calling it population C at the moment, because it's not gone through there. There's 1058 there and 1325. So it also allowed us to sort of look at replicate gating, because we've got the same sample in some populations in the beads, but different to the actual target cells. So how did we do? Didn't do too bad. We've got some quite nice, these are actually not bad CVs in terms of the CD45 events. If we just look at gating of CD45, folks do quite well. We've got nice tight CVs. The problem comes when we actually look at sort of maximum number of events reported. Well, people are going to get the maximum events, that's fine. But then the minimum events, we do have a couple of laboratories here that don't seem to have gated on all the CD45 events. We're not quite sure why. So we've got some laboratories that are not gating correctly on CD45. For CD34, everybody said they were using the ICH gating strategy. Again, if we just look at the events, we've got some nice sort of tight SDs around around the robust means. But again, we've got some really big differences in the actual maximum and minimum. We've got an order of magnitude between in fact, here we've got almost 2 orders of magnitude. 1,400 CD34 cells identified by one lab, 19 identified by another. So we are seeing some really big differences, which again is very worrying. Of particular concern to me was the bead count, because on this one, because we'd issued an electronic trial, we could ask you guys to gate on the beads, and we could sort of use that to check how things were going. And as I said, the beads in sample 1 and sample 2 were the same. They were 100% the same. So why have we got different answers for the maximum number of beads, and why have we got different answers for the minimum number of beads? Actually, why have we got so many different answers, from 81,000 beads down to 2,000? That's another question. But it was interesting that 3 laboratories had got bead counts that differed by great percent on the same population, analysed by, I'm assuming, the same. So it's quite concerning. The effect this had on the absolute counts, well, you can see it there. We've gone from, again, we've got nice sort of tight tight SDs for these samples, but again, it's quite worrying. Reported by 1 versus 11. I'm hoping that's a calculation error. But then 151 CD34 count compared to 3. It's a big difference. So we're seeing a lot of variation in these electronic trials. So we know that this is all analytical error. This is not a pipetting problem. This is not somebody using the wrong fluorochrome or the wrong clone. This is not a sample fixation issue, because these were fresh samples that we acquired. This is just drawing of a gate, and we've got problems. One other thing that we could do is, because we asked laboratories to report all of their values for the events counted, and also to report their final numbers in terms of absolute counts or percentages, how we constructed the data entry page meant we could check the maths that the laboratories had done. We did that. We found we've got a significant number of laboratories where their values differed from the numbers that we got by greater than 5%. We used 5% because of rounding issues in Excel, and thought that was a nice sort of reasonably safe number. But when we actually put the numbers through our computer software, we found 35% of laboratories made at least one calculation error on the EDU-A, and 33% of laboratories made at least one calculation error on EDU-B. That's a lot. What we also did is we compared, because we've issued over the years so many wet samples, we've actually got matched pairs. So I went through our database to find where we'd got a wet sample that had got a count the same as the electronic sample. So that's why this isn't actually a linear graph. So this is where I found the sort of nearest matched wet sample. And we can see from the CVs, CVs on the wet samples are always higher. But the actual red bar, which is the CV on the electronic trial, is surprisingly high, which is saying to us that the majority of error in flow cytometry is actually analytical. On average, it's around about 60%. If we have a look on the absolute counts, now you will notice there's only 4 data points as opposed to the 5 data points there. That's because the 5th data point, which kind of sits here, had a count of 600 CD34 cells per microliter. We've never issued a wet sample like that, so I couldn't have a sort of a corresponding neighbour to actually plot it against. On the 4 where I did, again we can see the wet sample error versus the electronic sample error. Again, wet samples have got more error, but just the analytical error is surprisingly quite large. Again, averages out about 60%, except on this one where it's about 45. Well, this is low to about 45, but on average, it's about 60% of the total error on a traditional sample. So what did this tell us? Well, we think we've got issues with gate placement. We think we've got issues with results calculation. As I say, 33% of laboratories making calculation errors of greater than 5% on one or more of the samples. This did concern us, and we wondered if this had actually been ongoing for a long time. So we had a quick look in our database at the percentage CD34s. We can't check for absolutes because we don't always capture your bead count and your bead batch numbers. So we could only check the percentage values. When we looked back to 2004, to the last sort of 20% of the results don't match up so that we've been entered. So either data that's been provided to us is being entered wrong, or laboratories are making calculation errors on their percentages, or a combination of both. But either way, that's worrying because we've got potentially issues with maths or issues with results transcription, both of which are quite concerning for us as an EQA program and for yourselves when you're getting things entered into different databases. So, the MRD trial. So we've done the CD34s and thought that's interesting. Let's see what we do MRD. So we used ALL, who issued this last August. 2 samples, both derived from patient material. Stained them locally with the panel there, CD38, CD10, 20, 94 and 45. I'm not endorsing that as a panel. I'm not recommending it or anything like that. It was just we thought people would be familiar with all of these antibodies and the staining patterns. It just seemed like a nice starter for 10. Straight away, we ran into problems when we said to people, what denominator do you use? And we got 9 different answers from the 51 different laboratories. So we've got mononuclear cells, total nucleated cells, total white cells, and the non-erythroid populations. And then other, so 6 out of 51. So these are the other 6. You know, there's different ways in all these things. I think it's well, it tells you what it is itself, doesn't it? Really, all the different ways of actually doing it, which is interesting. In particular, I've found this one to be of note is that they actually change their target cells depending on what day they're actually testing, which is again an interesting way of doing it. As is FICAL preparation, it's quite old school. To do for this is we decided to focus on the total nucleated cells and the total white cells populations. So again, this is electronic data, so the only differences that we do here are due to gating. So again, we've got nice tight CV here, so 99,000 events with a SD of 848, a bit wider SD when people are using total white cells and non-erythroid populations. And not too bad for the sort of maximum minimum events there, but quite worrying maximum minimum events there. We somehow we've got a laboratory that's got 55,000 events, and then we've got other laboratories that's reporting 100,000 events. It's the total nucleated cells. It's got to be one or the other. You can't suddenly lose half of the cells. when we actually look at the MRD events, total nucleated cells 136, 123 on total white cells. So that does compare quite well. A nice tight SDs, but again, quite a big difference. Nearly sort of a threefold difference between the maximum events and the minimum events. We saw the same on spread of events counted, and a massive spread here of MRD events. So although we've got nice tight SDs and tight CVs, the outliers are very worrying. 5,000 tonight. So if we translate that into actual MRD, the minimal residual disease population we've got, so 0.14, 0.13 between the two techniques, that's not bad. With an SD of 0.01, this is fantastic, that is brilliant. But we do have some big outliers. Here we've got sort of twice the level, so 0.24, and here we've got half the level of MRD. That's worrying. For the total erythroid population, 0.14 is not too bad, but again, 0.08 is a little bit low. What really worried me was sample 2, where the maximum result that we got is 5.7%. That's not MRD in anybody's book, that's just disease. So I was genuinely surprised and quite worried at that result. And again, we've got large, the difference between the maximum and the minimum is an order of magnitude. Right. It's not right. We've got to try and figure out what we're doing here. Again, I did actually compare the in vitro versus the in silico. So I found the nearest wet sample that we'd done. So the blue is the CV on the wet sample. The red is the total CV on the electronic sample. Now what I also did is I also plotted the total nucleated cells CV in green and total white cells non-erythroid CV. This comes back to what Debbie Lencross was saying this morning when she was talking about keep it simple. Simple approaches sometimes. And actually, the total white cells and non-erythroid is a few more gates that require drawing. And interestingly, we've got higher error. So what this is suggesting to me is that as gates, the gates should be purifying and making things cleaner. It's actually saying we're making problems for the cells, presumably because of gate placement and then the underlying logic causing issues, I would imagine. Again, we checked the maths to see if there were any mathematical problems and calculation errors. We only found 2 laboratories on each sample, so 4%, at least one calculation error over the 2 samples. I still think that 4% is too much. I think that's, again, very worrying that we're getting calculation errors or data entry errors, whichever way you want to say it. With the MRD, well, there's differences in denominator population choice, clearly differences in gate placement, and we've got issues in calculation, although not as many issues as we saw on the CD34. So, laboratories making other problems that we've identified when we were doing these studies. FCS files are as commutable as they're advertised. People say, oh, you can ship stuff. Yeah, you really can't. There's lots of issues that relate to the analysis software. It's not actually the FCS files themselves. It can be the older software packages. It's quite often are unable to open software that's been acquired, FCS files that were acquired on the newer software packages. I'm not quite sure of the sort of legacy systems that companies put in place, but this is something that we did see, that sort of people with the older software packages just couldn't open the files. So if you have got sort of newer versions of the software, also might not open your old files. We also saw the reverse version of that. So even if it's from the same analyzer, if you're using version X and historically you used version Y, you might not be able to open them. So we'd really recommend that you guys make sure you can open any historic files that you're storing. We know that people for several years. If you are going to do an upgrade, maybe keep your old version and put the upgrade on a separate computer to check that you can open some of your legacy files. Otherwise, you're just going to have a hard disk full of FCS files that you can't do anything with. And we found, I think it was over these exercises, between 5 and 10% of laboratories that were participating couldn't open the files. Try as they might because of the software differences, and try as we might because we only could create software in the latest versions of the packages that we're going to create FCS files into the software. So, in summary, it looks to us like the main error in sample preparation is not actually technical. It's not what we're doing at the bench, it's analytical when we're actually sat at the flow cytometer. We've seen massive differences in gating practices between laboratories, lots of inconsistent and inaccurate mathematical calculations being performed. And it does seem to us that the analytical error is about 55% of the total variation in the clinical results if we're going to use CV as a measure. So the question is where we're going to go from here. We're going to carry on doing electronic trials. We do actually think they're beneficial, so we're going to issue them as educational trials in addition to the stuff that you guys are already doing. So we're going to do a few more CD34s, we're going to do some more MRD ALLs. With Steve's help, we're going to do a PNH, and hopefully we're going to do a plasma cell, as we were just talking about there. But there's value in the electronic trials, in that it shows us pure analytical error, and there's also value in the wet trials, because that's the combination of the technical error as well. So we're always going to be running both, but we are going to be running more of these electronic trials because they really are very informative. And I think what we will do next time is if we start getting these calculation errors coming through and the typos, I think we will start following up a little bit more with the laboratories and actually seeing if we can drill down and find out where things are wrong. Is it the data entry sheet that we've designed is not what user-friendly? Is it a genuine issue in terms of the calculations that are not being made correct? I think it's probably 50-50. So that's what's going to come to your direction over the next 12 months before over the course of the coming year. So that's it for me. I'm going to finish a little bit early. The only thing that I would put up is, as always, we've got a request for samples. We always need patient material, the leukemia immunophenotyping, the PNH, and the MRD programs. If in doubt, just give us a call. The molecular team, they've got slightly different requirements. We can't actually fit it all on one slide. What we are going to do, we're going to email all of the laboratories. We'll send out to laboratories the kind of samples that we're looking for. Just give us a call. We'll arrange transport if you've got a suitable case. We'll provide consent forms if you've got clinicians that like taking samples off patients, or bear in mind that any waste material you have in terms of clinical audit can be used for EQA. Under the Human Tissue Act, waste material can be used for training and clinical audit, and EQA is clinical audit. So if you have waste material, you don't even need to consent the patient. Everything we use is anonymised. Nothing comes back to the patient in that regard. So please, if you do get any samples you think might be useful, any interest in leukemias, any, let's say, PNHs, give us a call. We'd be very grateful. Thank you very much.
Thank you, Liam.